Hi, welcome to a product review by watthour. In this video we are going to do the review of this DPS5020 50 volts 20 ampere constant current, constant voltage with tons of protection with mobile app and PC software. I'm going to explain the module, then under the magnifier we will look at the components of this module. After that I'm going to explain the settings, how to set this. After that I'm going to do the test with all standard voltages from 50 volts. I'm going to show you the efficiency. We are going to see also the ripple for major voltages under different load current. After that I'm going to show you how to set up, how to download and install PC software. Then after that I'm going to show you how to install the Android app, and then here, if you want to purchase this, the link is below the video in the description. Let's get started with this. This is a detailed video. On the larger screen, click on this area of the player so you can see all the chapters. On your mobile device you will see the menu. When you touch it, you'll see all the chapters, and then click and touch to move to that section of the video. This is DPS5020, which means the output can go from 0 to 50 volts and the current from 0 to 20 ampere in all voltages. It can be controlled via PC, and also it comes with Bluetooth, so you can use mobile app to control it. And it has tons of features. I'm going to explain all the specification. Excellent screen and dial. You can turn on and off. It has memory, nice dial and controls, very bright. It can be installed on a panel. A case is also sold for this, so you can also get that one and properly install it. This is sold $40 US and $10 shipping. With a USB version, $43 for the $10 shipping, that's $9.63. And then if you get USB and Bluetooth, it will be 46 plus 10, about $56. Cases are sold for DSP, so you have this type of case, or the case with all this accessories. So this module fits here 5020 with USB version. So this is $13 plus $14.43 shipping. Now let's have a look at the specification and features of this Ryzen DPS5020 USB BT. The module, you can purchase it either with this piece, or you can have this module, which is a Bluetooth, and also you can get the Wi-Fi. In this presentation we will explain DPS5020 module. Briefly we will look at the components under magnifier. Settings will be explained, and then the input-output voltage, minimum and maximum, will be shown, and maximum output power and current will be tested with different voltages and different current and efficiency at each step. I'm also going to show you charging lithium iron or lithium iron phosphate battery. I'm going to look at the switching frequency on oscilloscope, and the ripple voltage also will be shown. So this module has the following protection: constant current, constant voltage, which means you can set the constant current. It will never go above that amount of ampere that you set, or that value for the voltage. So you will set one of them and the other will be adjusted. Input reverse polarity protection, output over voltage protection, OVP, over power protection, so you can set the power, for example 500 watt, and it will never go above that. Over current protection, and if you draw more than set value that you set for overcurrent, it will prevent it. Even if you set overcurrent protection for 10 ampere and by mistake you set the current For 12, it will prevent it. And over temperature protection, the system has a preset temperature value, and it will shut it off when it's heating up. It has high definition 1.44-inch LCD. It comes with a PC software if you purchase the Wi-Fi and Bluetooth module, and it comes with a mobile app. And 10 memory preset where you can save your settings, group of settings, power, voltage, current, all the settings will be saved. So by recalling the memory, all the settings will come from 0 to 9, so 10 memories. On the main display, you can see output voltage, output current, output power, input voltage, constant current and voltage, the set value that you have, the set current that you have, and status indicator. This is a lot of information on the same screen. And status indicator will show like that, over voltage protection icon, over current protection, over power protection, and over temperature protection icon will be displayed once the protection is activated. So here are the specification. Input voltage is 6 volts to 60 volts, so you cannot input less than this. Output voltage can be set between 0 to 50 volts. You see this 2-digit, which means you can set up to 10 millivolts here. Output current 0 to 20, all range, and output power maximum 1000. Now pay attention to this. If you get 50 times 20, that's 1000, which means with the maximum you can get it. So below that for sure it will supply, but we will test it. Now the resolution that you can set is 0.01 volt or 10 millivolts. The same way for the current, 0.01 ampere or 10 milliampere. And voltage reading accuracy, that it reads is plus minus 0.5% plus 3 digits. So 0.5% and 3, and 0.05 for the current, the same. Now this is very important. When you input a voltage, the input voltage must be greater than 1.1 volt of output. What it means is, if you want output to be 12 volts, then 12 times 1.1, it's 13.2. So the input should be 13.2 volts in order for you to get so you have to have 13.2 volts at the input, so you can get 12 volts. The fan will run when the temperature reaches 45 or higher, or the current is greater than 10. So when you are operating at a current greater than 10, it continuously runs regardless of the temperature. I'm going to test it with input of 60 volts and output of all these values, and then change it to 48 volts industry standard voltages, and change all these voltages, and 36 volts. Well, with all these voltages will be 24 volts with all these voltages, and then 18 volts with all these voltages, 12 with all these standard voltages, and then I will reduce it to 9 volts with these voltages. And then the lowest voltage is 6 volts, and we will test it with 5 and 3.3 volts. I've spent 2 full days to make this video. The only thing that you can do for me is to subscribe and thumb up the video. Thank you. So please don't forget to subscribe by clicking at the subscribe button. I really appreciate it. This is a package. When you purchase it, you will receive something like this. And the model has been labeled as USB Bluetooth, so you can get different version of it. I'll provide you the link. You can purchase it from the link below. It will also help me with some commissions. So here there is a QR code to download the application. I have these 2 pieces or 2 components included. So this is the Bluetooth module, BT, and this is the USB. So nicely packed. The control panel and 2 wires that are needed to be connected in here. Now let me explain the module. This is the input with 2 terminals here. We have these connectors where you can connect them with a screw, and these can be soldered or crimped. That's very nice. The same way for the output. So we have 20 ampere input fuse, and also we have 220 ampere fuses for the output here. This is the shunt resistor that measures all the current. So all the current passes through this, and the voltage that appears across this resistor is representing our current, which will be displayed on the screen or measured with all these components below this. The fan is 5 volts, which can be easily removed. We have 2 screws here, and then the heat transfer sheet is also in here. This is working based on pulse width modulation and then STM semiconductor microcontroller with the rest of the components. Because it has input reverse polarity protection, we have here 2 16 ampere MOSFET that is used as a switch to detect the input polarity and disconnect it. And this is the main inductor, the switching inductor for the back converter. These are the capacitors that are needed for the input, and these are for the output. If you pay attention to the voltages of the input, as you can see, this is 63 volts, meaning any voltage above 63 will make this explode. This standoff from the bottom also protects this module with enough space, also for air circulation as well from the bottom. Well built. 2, and then we have 2 connectors. This is labeled as LCD and this is labeled as key. So we have two of them. For both of them we have 2 cables. Play is very simple. If we remove it, we see that this has been labeled as LCD, which will be connected to this, and this is labeled as key, which will be connected to this point. The display has this rotary encoder with push. That's very nice. This is not a volume or potentiometer or resistor. This is just actual rotary encoder with on-off switch, and then up and down set, and also memory 1. You can change the memories by pressing these buttons. This can be installed on a panel where you can insert it. It will snap. The hole should be 71.8 millimeters by 39 millimeters, 39.2. Depth of this is 24.8 millimeters. The width of the module is 9.3 centimeters by 7.2 centimeters. And here is the USB chip module for PC connectivity. When I scanned it with my phone, this is the page that opened 5005, 5010, and 5020. Let's see. What is that? Get? No. Let's click and open it. The CNC communication protocol, factory support, and operation and PC app instruction. Let's have a look at the model of this chip under the magnifier. BK3231, 16 megahertz. Let's just open this so we can see the components underneath. So we have this fan. Let me remove it. Now let's have a look at the component under the magnifier. The magnifier that I'm using is Andon Star with the biggest component, and this is the 32F100 microcontroller from ST Semiconductor. This is the TL594C. Here's the data sheet for TL594. This is a precision pulse width modulation chip. The chip that we are using is this one. Maximum frequency is 700 kilohertz. This is the LM321. This is a single operational amplifier. Let's have a look at this. 86260C 260. This is a LED current regulator, but we can use it for anything else. So this is a current regulator. And this is XL7005A. Here is a data sheet for XL7005A. This is a 400 milliampere, 150 kilohertz, 100 volts step down or back converter. And these two chips are 4262E. There is a data sheet for 4262E. This is a 60 volts N-channel MOSFET. And this is amazing. The current that this can handle is 16.5 ampere. It's a switch that has very low dropout. As you can see here, these are all drain, these are all source, and it has gate here. So drain, source, and gate. This chip is 5106. Here is a data sheet for 5106. This is a high voltage, low side driver. This is a Schottky diode, and this is the same 4264. This is the MOSFET. Now let's have a look at this. This is GS8332. Here is a data sheet for GS8331 and 8332. This is zero drift. This is 350 kilohertz, zero drift CMOS rail to rail IOUT IO op amp with RF filter. This is M5333B. Here's the data sheet for M33B, and this XX here is 33. So our model is in here. It's 3.3 volts voltage regulator. And here this is one chip, SSF5709. And here is the data sheet for SSF7509. This is 75 volts, 80 ampere with RDS on of 6.5 milliohm. When drain source is turned on, the resistance will show at 6.5 milliohm, typical. So this is the 20 ampere fuse, which is connected beside the input pin. Also, we have two 20 ampere fuse. We have this 7133H. Here is a data sheet for 7133H. So this is 71, and as you can see, this is low power LDO. So 33H is low dropout. This is also a regulator. And let's open the fan. And as you can see, this is a 5 volts DC motor. When working with this, make sure do not remove it multiple times, because every time we bend this, we are damaging it, and it's possible that it will break. Let's insert this. The first one is LCD, and we will connect it to this connector labeled LCD. And the next one, keys, it will be connected. And here. So I will be using these wires. I have connected 2 wires into one. So this is one connector, but you can do 2 wires together. You can do something like this, 12 gauge wires. You can use 2 for the input, 2 for the output, because this is 8 gauge wire, 8 AWG, and you cannot solder it. So I have connected them. This is just one piece of connector, even though it has 2 wires, but this will be for negative, this is for positive, and the same way in here. Because I already have it, I'm using this with a connector that is available. To tighten it, you need to hold it with a plier, otherwise this piece will rotate, that small plate. So hold it like that and then tighten it. We connect it. I'm checking the voltage, 14.6 volts. So it booted up. And it shows 14.74 volts at the input. And if I press it, now my load is 1 ampere, that's 35 volts is outputting. So this is the output voltage, output current, and that's the power. Let me explain the settings and knobs. So we have up and V, and we have low and current or ampere. And then we have M1, M2 set on off. This is the set voltage for the output, and this is the set current for the output. So this is at the moment the voltage is 40 volts at the output, and the current is set for 20. This is the input voltage, and here, which is now 60.9 volts. And then we have the rest of these settings here. This is lock. This shows that everything is okay, otherwise the protection will show here, and then the type of protection will show here. Currently it says constant voltage, and it is okay, and it's holding that voltage. And this is turning on and off to show that if the device is on, you see when I turn it on, it turns green and then red. To set the output voltage and current, we can do it 2 ways. First, we can just press this button and the highlight will appear, and we can rotate and change the output voltage. If you want to go to the next one, just press it, it goes to the next one and to the next one and so forth. To set the current, if you just press it, it will exit. To set the current, press A. Now you can set the current, press set and exit, press the same button. This was setting it via that menu, but we have the set button. We can press set button, all these options can be set. Now this is for voltage setting, this is for the current, over voltage protection, over current protection, over power protection, and then LED brightness, this screen brightness, and then memory that's a preset value. And we have, if we come with this arrow, the highlight goes down, and one more will show here, that is the initial set value, when if initially the device should be on and off or not. I'm going to show you one by one. When we are in here at this value, just press this button, it will move. Now we can set the voltage any voltage you want. You can set up to 10 millivolts. So this is now 490, 450. So that was 490, 500 millivolts, 510. So 35 volts and 510. So 10 millivolts every time we rotate it. Once you're done, press it. Once you're done, press the set button. It comes here and done. If you do not press anything for 30 seconds or so, it will exit from this screen and it will go back. Now we can go with this arrow, come to the current the same way. You can set the current here and set exit. If I press set exit again, you can exit from that screen. Now let's go down. This is over voltage protection, set to 51, over current. You can set it. So what is over voltage protection and set voltage? Over voltage protection is the voltage that you want to prevent setting. For example, right now the voltage is 35. Now this over voltage protection, if I come down, is now set to 40 volts. So let's say you want to set it to 42 volts, exit and exit. Now the output is set to 35 volts, 5 ampere maximum. And if I press it, now my load is 1 ampere, that's 35 volts is outputting. So this is the output voltage, output current, and that's the power that we can see. But if I, for some reason, if I press V and 36, pay attention, if I go to above 42, it is working. So 40, 41, 42, and just 42.0 constant voltage, it turned it off. So it does not allow that value. If you want to actual 42, then we have to set this to 42.1 or something. $100 millivolts extra. And now if I turn it on, 42 will be allowed. So that is very useful feature to set the value. The same way for the current, you can set your current. Let's say you want to work with 10 ampere and set it to 10 or 10.1. It will never go above 10. You cannot set it. Even if you change it, it will reject it. This is over power protection. So sometimes you want to set the power, let's say 200 watt. So set the power and it will keep it. If I come down, this is the brightness of the screen. 4, 3, 2, 1. If you want to save energy if needed, let's put it to 5. And then this is the preset memory. So if the memory should be turned on automatically or not. Right now it says 0. As you can see, we can increase it. We can have 10 memories for each. All the settings will be set for that specific memory. And the output is now off by default. When you go to the memory, I'm going to show you, it will have effect. How we can recall memory. Those are the basic settings. Now, this button is by default memory 1 and then memory 2. If you hold it for a few seconds, so memory 1 is loaded because it was off automatically. The voltage is 14.6 and the current is 5 volts. It is memory 1. If you want memory 2, just hold it for a few seconds. Now memory 2 is loaded, 5 volts and 20 ampere. By default, automatically is set. If you press set, you come here down to press this button, and from here, let's say you want to go to memory 5 and you want to set the voltage. After that, press exit, go back, press set, go back, and let's say you want to set it to 48 volts. And the current come down to 10 volts And after all of this, then press set until you see M5 in here. So M5 is saved, press set to exit. Now the value for set press again, the value for M5 is not here. Now to bring M5, press set and hold it for a few seconds. You will see here, go to M5, and after that press set. As soon as you press set, 48 and 10 appears, and this way you can set and recall. Now the memory was recalled, but the output is not on. I have to press on and press off to turn it on. But to make it automatic, press set, go down, and then in here, memory 5, and then press this again and make it on. Again, hold this for a few seconds until you see M5 in here. Wait. M5, and now exit. Exit. For example, M4 is off, M5 is on. If this is on, when you recall it, if the output is on, it will go on automatically. If not, it will not. So let's see, 4 is off, and I'm exiting, and 5 is on. Let's go to 4, press set, and then go to now let's turn the output on. Output is on. Let's go to number 4, memory 4, press and hold until you see 4, and then set, exit, and as you can see, it turned off because 4 was off, and 5 is on. That's now to show you 5 is on. 5 is on, correct? So I'm exiting, holding. No, first turn on, output is on. Let's go to memory 5. Hold 5 and then exit. As you can see, it is on, it did not turn off. Set, if I go down, this is the value. If you set it off, initial turn on. So now exit, exit. Output is now off. I'm turning my input power off. So now it's off. Now if I turn it on, it is turning on, and output is off, as you can see. Now if I press this button, go down and turn it on, and power is disconnected. The power is disconnected. When I turn it on, automatically the output will be on. You see, automatically the output is on because we set this to on. But this is not a good idea to leave it unless you need it. I will keep it off because we can turn on and off from here. Of course, this will work once it turned on, but that is just for initial boot. Now let me show you how we can charge a lithium battery. We have to know the following first: maximum charge voltage, we must know it. We must know also maximum charge current. And for lithium ion NCR18650, the maximum charge voltage is 4.2 volts, and people call it 3.7 volts. That's a nominal voltage. And charge current is maximum. You can go 1.65, but you can go lower, but that's the maximum. For lithium iron phosphate, when people call it 3.2 volts, it's actually the charge voltage is 3.65 volts. So we have to know this before we proceed with the charge. And the charge current, you can look at the data sheet, but that's the maximum. You can always go with the lower. The best practice for charging battery is to divide the capacity by 10. For example, if we have 3000 milliampere hour battery, 3000 divided by 10 is 300 milliampere. So that should be the charge current for that battery. And here, this is the example of 3-cell batteries. These are the nominal voltages for the battery. If we connect them in series, then we will use the top and bottom for the main load and charge. And because the charge voltage for the lithium ion battery is 4.2 volts, then 4.2 times 3 is 12.6 volts. That's what we set the voltage in our charger. And here is the example of 3 cells connected in series. This is the positive, the bottom is connected in here, the top is connected in here. So in series we have one negative, one positive, where we can connect it to our load. If we have 3 cells, we connect them in series and multiply the voltage. For example, if we have 4 cells, and then here one cell is 3.65 volts, and because we have 4 cells, multiply it by 4, and the charge voltage is 14.6 volts. Once you have the charge voltage and maximum current, then the module set the voltage at the maximum charge voltage, and for the current, set the constant current to the maximum current that you have for the battery. Let me explain the constant voltage, because I've seen many people have question with that and they don't understand the meaning of constant voltage. Constant voltage means that the input that you see here is 60 volts and the output is set to 45. Now this one I can change it. It can go, let's say, 48, 50, 51, 52, up to 60. So it can go up and down, and output is stable. Let me show it. Just pay attention to this point. So now the output is set to 45, input is 56. And if I go even 49 or 48, the output is 56. So that's for solar panel and other stuff that you use. It will be very nice to set your minimum, but there is one condition. If I go below 45 point something, remember I give you a number times 1.1. So let me reduce it. Now it is being reduced because it cannot keep 45. This is 47. So I have to go higher. Now 49 will give me 45. So that is the meaning of constant voltage. Now, what is constant current? Constant current is the value that you set. Let me set here constant current, and I'm setting it at 10 ampere. Now, if my load takes 10 ampere, now 10 is on. Now this will allow up to 10. Now let me go and increase it. 12. I'm setting here 12 and clicking. As you can see, this is now asking for 12 ampere, but this is saying that I'm giving you only 10 ampere because the constant, the current is now on. In order to keep the current at 10 ampere, we have to reduce the voltage. So the voltage is now 190 volts, millivolts, 190 millivolts, and the current is 10 ampere because it says constant current. Now constant current is having priority and controlling the voltage. Turn it off. Now the voltage is back because the current is 0. But if I go to and use 5 ampere and turn this on, 5 ampere and turn it on, as you can see 5 is okay and the voltage is also okay. This voltage will be reduced only when the current goes beyond the set value 10. When the current is just above 10, it will reduce the voltage in order to keep it. Let me show you one more thing. So I'm rotating this. You will see it here. 9. So 10.2. You see the voltage was reduced immediately. 9.7. 9.7 is okay because it's below 10. So that was constant current. And here is my wiring. I've connected the input in here. This is the output. It goes to the load. I have a power supply here. The power supply that I use is 0 to 60 volts and 30 ampere. The link for the power supply to purchase is below the video. This goes to my electronic load, where I'm going to show you on the screen. You don't have to connect this type of wire. Just use this 12 gauge wire for 20 ampere. It will be fine. Now let's start the test with. Now let's start the test. I've zoomed in so you can see it. Here we can see the current, we can see the voltage, and we can see the power. The resistance is shown by Ohm's law, but we are not worried about it. So voltage and current or power is important for us. And currently I set it to 1 ampere. This is 0.9995. And the voltage is also shown, 48 volts, and that is 48 volts. I have turned on the sense voltage, and I have here separate these two wires connected to sense the voltage, so we don't have any drop on the line. Now I will show you the input current. This is the input current, and then we can see the voltage here. As you can see, it says 60 volts, 60.6. So the voltage is shown. The only thing that we need for the input current is this value here. But the rest for the output, we can see it here. And we can see them in here. Let's get started. Now the output is 50 with 1 ampere. Input current is 850 milliampere. Let's go with 5 amp. So here now output is 50 volts, 5 ampere, and input current is 4.17. Here is the efficiency. Let's go 10 ampere. 50 volts, 10 ampere. Input current is 8.4. And here is the efficiency. I'm going 15. And as you can see, the output is 0, and it says here constant current. Let's check. Turn it off. Let's check. Constant current is set to 10. Let's change it. 20.1, and then exit. And now let's turn it on. Now output is 50 volts and 15 ampere. This is now not accurate as this lab equipment. This is very accurate. Input current is 12.74, and the fan is running. Here is the efficiency. Let's go 20 ampere. And as you can see, the output was turned off, and it says constant voltage. It did not allow 50. So it seems we cannot go 50. Let's set it to let's set it to 49.7 or something. And here now let's turn it on. 49.7 and 20 ampere. Input current is 17.03 ampere at 60.28 volts. Here is the efficiency. Now I've set output to 36 volts. At the moment it is 1 ampere. Input current is 630 milliampere. Here is it. Let's go to 5 amp. Output is now 36, 5 amp. 3.05 ampere is the input. Here is the efficiency. Now output is 10 ampere, 36 volts. Input current is 6.1 ampere. Here is the efficiency. At 10 ampere the fan is not on. 15 amp. So 15 ampere, 3615. Input is 9.323 ampere. Here's the efficiency. Now I turn the output to 20 ampere, 36 volts. Input current is 12.42. And here is the efficiency. Now the output is 24 volts. Let's go to 5 ampere. Output current is 5 ampere. Input is 2.07. Here is the efficiency. Output is 10 ampere at 424 volts. Input is 4.13 ampere. Here is the efficiency. Now output is 15 volts, 24 volts at the output. Input is 6.21 ampere. Here is the efficiency. Now output is 20 ampere, 24 volts. As you can see, this is 481 watts. Input current is 8.35 ampere. Here is the efficiency. Now I've set the output to 19 volts. Some people need this for laptop charging or laptop powering, whatever it is. So let's go with 5 ampere. Output 19 volts, 5 ampere. Input current is 1.65 ampere. Here is the efficiency. Output is now 10 ampere, 19 volts. Input current is 3.28 ampere. Here is the efficiency. Now output is 19 volts, 15 ampere. Input current is 4.95 ampere. Here is the efficiency. Now let's go with 20. Output is now 20 ampere, 19 volts. Input current is 16.66 ampere, 402 watts. Here is the efficiency. Now I set the output to 12 volts. Let's go with 5 amp. Twelve volts, 5 ampere. Input current is 1.06 ampere. Here is the efficiency. Twelve volts, 10 ampere. 2.11 ampere is the input. Here is the efficiency. 12 volts, 15 ampere, 3.18 volt ampere input. Here is the efficiency. Now the maximum current 12 volts, 20 ampere. Input current is 4.29 ampere, 259 or 260 watts at the input. Here is the efficiency. Now I've changed the voltage to 8.4 volts. That is the charge voltage for a lithium battery. 5 ampere is the output. Input current is 0.76 ampere. Here is the efficiency. Output is now 8.4 volts 10 ampere. Input current is 1.51 ampere. Here is the efficiency. Now output is 8.4 volts 15 ampere. 2.28 ampere is the input. Here is the efficiency. Now output is at the maximum 8.4 volts 20 ampere. Input current is 3.08 ampere. 186 watt at the input and 167 watt at the output. Here is the efficiency. Now output is 5 volts, 5 ampere at the output. So input is shown here. 0.47 ampere is the input current. Here is the efficiency. Five volts 10 ampere. Input current is 0.94 ampere. Here is the efficiency. 5 volts 15 ampere. Input current is 1.42 ampere. Here is the efficiency. Now 5 volts 20 ampere. Input current is 1.94 ampere. Here is the efficiency. Now I've set the input to 48 volts. Output is 36 volts 5 ampere. Input current is 3.81 ampere. With the same voltage at 10 ampere, 7.61 ampere the input. At 15 ampere, 36 volts the output. Input current is 11.54. 36 volts 20 ampere. Input current is 15.53 ampere. The output to 24 volts at 5 ampere. Input current is 5.75. At 10 ampere, input current is 5.14 ampere. 24 volts 15 ampere. Input current is 757 ampere. And maximum 24 volts 20 ampere. Input current is 10.42 ampere. Now output voltage is 19 volts. Output current is 5 ampere. Input is 2.05. At 10 ampere, input current is 4.09. At 15 ampere, input current is 6.18. At 20 ampere, input current is 8.31. Now output is 12 volts. I set it to 5 ampere. Input current is 1.32. At 10, 2.63. Input current is 3.97 for 12 volts 15 ampere. Now finally 20 ampere 12 volts output. Input current is 5.35 ampere. Now I set output to 8.4 volts 5 ampere. Output input is 0.94. Let's go 10 ampere. Input is 1.87. At 15 ampere output, input current is 2.83 ampere. At 20 ampere is 3.83 input current. Now 5 volts 5 ampere. Input current is 0.58. 10 ampere 1.16. Now 15 ampere is the output. 1.76 ampere is the input. And maximum is 20 ampere. So 5 volts 20 ampere. Input current is 2.4 ampere. 3.3 volts 5 ampere. 0.41 ampere is the input. At 10 ampere, here is the efficiency with 800 milliampere input. 15 ampere 3.3 volts at the output. Input current is 1.23. 3.3 volts 20 ampere. Input current is 1.68. Now 36 volts, 5 ampere, input current is 3.41. At 10 ampere output with 24 volts, input current is 6.83 ampere. At 15 ampere, input current is 10.32. And finally, output 24 volts, 20 ampere, input current is 13.9. Now output is 19 volts with 36 volts input. Output current is 5, input is 2.72. At 10 ampere, input is 5.44. 15 ampere, input is 8.22. 19 volts, 20 ampere. 19 is for charge voltage or powering laptops. Input current is 11.08. Now with 36 volts input, output is 12 volts, 5 ampere. Input current is 1.74. Here 10 ampere, input is 3.49. At 15 ampere, input is 5.27. 12 volts, 20 ampere, input current is 7.11 ampere. Now output is 8.4 volts, 5 ampere at 36 volts input, 1.24 ampere. At 10 ampere, 2.48 ampere is. At 15 ampere, input is 3.76 ampere. Finally, at 20 ampere output, input current is 5.09 ampere. Now 5 volts, 5 ampere with 36 volts input. Input current is 0.77 ampere. Here at 10 ampere, input is 1.53. At 15, 2.33 ampere is the input. At maximum 20 ampere, 5 volts, input is 3.17 ampere. Now with 36 volts, output is 3.3 volts with 5 ampere, input is 0.53 ampere. At 10 ampere is 1.06 ampere. At 15 ampere output, input is 1.62 ampere. At 20 ampere output, input is 2.22 ampere. Now input is 24 volts. Output is now set to 19 volts, 5 ampere. Input current is 4 ampere. At 10 ampere, input current is 8.05 ampere. At 15 ampere output, input is 12.26 ampere. And finally, at 20 ampere output, input is 16.6 ampere. Now 12 volts, 5 ampere. Output is 12 volts, 5 ampere, and input is 2.58. At 10 ampere is 5.18 ampere input. At 15 ampere, input is 7.85 ampere. At 20 ampere, we have 10.62 ampere. Now I set output to 8.4 volts, 5 ampere. Input current is 1.8 ampere. Now output is 10 ampere. Input is 3.64 ampere. Now output is 15 ampere. Input is 5.7 ampere. Now output is 20 ampere. Input is 7.65 ampere. I've set now the output to 12 volts. Input is 18 volts. Output is 5 ampere, 3.37 ampere. Now 10 ampere is the output. Input current is 6.81 ampere. 15 ampere, 12 volts. Input current is 10.45 ampere. And finally, at 20 ampere output, input current is 14.18 ampere. Now I've set the output to 8.4 volts, that's the charge voltage. Output current is 5 ampere, input is 2.4 ampere. Here 10 ampere output, input is 4.82 ampere. At 8.4 volts output, 15 ampere, input is 7.41 ampere. And finally at 20 ampere, 8.4 volts output, input is 10.08 ampere. Now I set 5 volts, 5 ampere with 18 volts. Output current, input current is 1.44 ampere. At 10 ampere, 5 volts, input current is 2.95 ampere. At 15 ampere, 5 volts for the output, input is 4.58 ampere. Finally 20 ampere, 6.25 ampere is the input. I've set 3.3 volts, 5 ampere with 18 volts input. Input current is 0.97 ampere. Now 3.3 volts, 10 ampere output. Input is 2.01 ampere. With 15 ampere 3.3 volts for the output, input is 3.15 ampere. And finally 20 ampere, input is 4.34 ampere. 8.4 volts now, there is the output with 12 volts input. Output is 5 ampere, input current is 3.52. 8.4, 10 ampere output, input current is 7.24 ampere. 8.4 volts, 15 ampere, input is 11.117 ampere. And finally, output maximum 20 ampere, 8.4 volts, input is 15.34 ampere, 32 ampere. Now 5 volts, 5 amperes at 12 volts, input current is 2.17 ampere. At 10 ampere output, input current is 4.41 ampere. At 15 ampere, input is 6.86 ampere. Finally, at 20 ampere, input current is 9.42 ampere. Now with 12 volts input, output is 3.3 volts, 5 ampere, input current is 1.47. At 10 ampere output, 3.3 volts, input is exactly 3 ampere. At 15 ampere, 3.3 volts, input is 4.73 ampere. 20 ampere, input is 6.52 ampere. Now 8.4 volts input, output is 5 volts, 5 ampere. This is approximate. Input current is 3.09 ampere. And at 10 ampere, input is 6.3 ampere. And at 15 ampere, input is 9.919 ampere. 20 ampere, input is 13.65 ampere. Now I've connected another meter to see the input current here and input power. Voltage is now 6 volts, as you can see it here. Output is 5 volts, 5 ampere. Input current is 4.16. Now at 10 ampere output, input current is 8.75. At 15 ampere, input current is 13.38 ampere. The output, you see this is not proper 20, it shows, but here it's 20. And if 17.85 is the input current. 3.3 volts, 5 ampere. Input is 2.71 ampere. And you can see the current here. Output is 10 ampere. And input is 5.97, that's 6 ampere input. 15 ampere input is 9.74 ampere. 20 ampere, as you can see, it turns off. 13.7 ampere is the input. I'm leaving this for a while at input 60 volts. At input of 60 volts, output 12 volts, 20 ampere. So see how much this is heating up, and I'm going to look at it using the thermal camera. Now I'm turning this around and see which spot is the hottest. And let me put my finger. You see this area shows 45 degrees. That's very so 47 degrees, that's very normal, but this is the hottest spot. If I hold this and put my finger, you see that is the hottest spot here. And perhaps this area and this area where my finger is, the coil is hot and this area is getting hot. But that temperature is nothing, and because it's 47 degrees, so this can handle at least 125 degrees Celsius. I'll provide you the link. You will come to this page, and this is a zip file. Just click and save it. And here, this is a zip file. Let's right click using zip extract here. So you will have two folders. One is Word, that could be the manual, we cannot read it. And so open this DPS5020 file, and inside this there is a RAR file. This is for the driver. My computer has already this driver CH341, but if you don't have it, double click and run it, and after that this one is .rar. I'm opening it with 7-zip. You can get 7-zip from 7zip.org. Extract here. Now it's creating that folder. Double click, and this is a file. Let's right click and check it with antivirus. Scan now. So no threat found. Let's double click and install it. It asks for the path. I'm accepting. It installed also for National Instrument. The software installation is almost complete. It asks you to restart. So let's restart. I've connected the USB module here, and from here it's connected to my computer now. That on the start menu, just type DS. Just type DPS. It says DPS5020 software. Open it. The software has been opened. First we have to connect. Right click on the start menu, go to device manager and see what port is. So the USB serial CH340 is port 10, COM10. Come here, select COM10. Everything else is okay. We should just say connect. Connection exception. So it did not connect. So this was off. Now I turned it on, connected the power to it. And now let's say connect. You see this is now green, which means we are connected. 61.2 volts, the input. Also it shows here, and so we will set the voltage here, perhaps 30, yes, and when I entered, the output is now 30. Changed. Let's set the current to 5 ampere. Now the current is 5 ampere. So let's go 30. Let's go 15. And 10 ampere. My load is drying, so we have constant current. Normal. What else? Brightness. Let's reduce the brightness. Nice. So this is working. Now what else? So we see it in terms of graph, and the voltage also can be set like that. 17.3 changed, reflected there. The current also could be 16. We have set it. It shows here. Now let's get the app for mobile phone. In your mobile, just open the browser and go to bit.ly/DPS5020. 5020. So let's go, and you will be taken to this page. There are software and then .pk, and then this one version 1.08, 1.02. These are two versions of the same software perhaps. And let's download this one and then download. We should get some warning. It might be harmful. Download anyways. So now the download is completed. At the bottom, let's open it, and it asks you, do you want to install it? Yes. So installed. Now we can say don't send, and it will ask you for modifying storage. Allow. What should I do? Install. So DPS, and that's the icon. Let's open it, and perhaps let's see if we can select allow, turning the Bluetooth on. Now it's English. Let's try it again. Let's put 0000 and click OK. Could not pair. Now let's do it again. This time 1 2 3 4. If it is connected, this light will be solid. After enabling the Bluetooth, when I click here, I can see here row dang DPS. Let's touch it, and I believe we got connected. No, yes, it got connected. It shows the voltage. Now I'm going to put them side by side, and as you can see, this is now solid, which means we got connection. Now let's see what we can do with this. Let me turn it on. So it doesn't work once the Bluetooth is connected because it shows locked. On from here. Now it is on 10 ampere. Let's change the output voltage, how we set it. Okay, so when I touch it, it gets highlighted, but how I can enter? So 19 volts. Once when you touch, then you can use this dial. Let's go for the current. How can I do it? Okay, that is the, so first you click on the value. So first you click on the value, and then you can rotate to change the value. It becomes, for example, 24. But if you want to do the decimal point, go there and then change it. It will change. Now the voltage is down. Let's go up. 44. So now this graph should go up, as you can see. And 15. I'm bringing it down. Now how can we select the current? Okay, so you will touch this title. Once you touch the title, then it will be available for change. Now let's make it 20 ampere. So now output is set to 20 ampere. The current is now at the maximum because 10 is here. This red is the current. So the state, you cannot do much. Now let's have a look at the ripples. Now output voltage is 50 volts and 5 ampere. and the ripple that you see here is 88 millivolts. At 10 ampere is 122 millivolts. At 15 ampere is 112 millivolts. And at 20 ampere is 158 millivolts. 36 volts, it's 83.2 millivolts. At 10 ampere, it is 105 millivolts. At 15 ampere, it's 122 millivolts. At 20 ampere, it's 79 millivolts. Now for 24 volts, at 5 ampere is 31 millivolts. At 10 ampere is 52 millivolts. 15 ampere, it's 83 millivolts. And at 24 volts, 20 ampere, it's 81 millivolts. At 19 volts, it's 44.4 millivolts. At 10 ampere, 89.6 millivolts. At 15 ampere, it's 115 millivolts. At 10 ampere, 89.6 millivolts. 15 ampere, it's 115 millivolts. And at 20 ampere, it's 91 millivolts. At 10 ampere, 49.6 millivolts. At 15 ampere, it's 51.6 millivolts. At 20 ampere is 51.6 millivolts. 5 volts output at 5 ampere is 36.4 millivolts. At 10 ampere is 15 millivolts. At 15 ampere is 16.6 millivolts. 20 ampere is 20 millivolts. At 10 ampere is 34 millivolts. At 15 ampere is 89.6 millivolts. At 20 ampere is 17.4 millivolts. Now here is my conclusion. This device in terms of voltage and current, perfect. Stability of voltage is amazing. The current up to 20 ampere in all voltages. I did the test, it's excellent. The efficiency is amazing and excellent, but certain voltages will not be desirable because of whatever setting or because of the difference between input and output or maybe some voltages. But overall, over 90% of all the currents and efficiency are amazing, perfect. And also it has 10 presets, so you can just recall with all the over voltage protection, over current protection, over power protection, constant current, constant voltage, recall it and see it. Another beauty of this is that it shows also the input voltage, and it would have been nice that if they had included input current and power, then this would have been the best. But regardless, this is still amazing. It can be used for battery charge, for everything. But one thing that I would say, that if you are planning to use it in your home or lab or school or organization, you must get the box. There is a case for it. I will provide you the link. The link is below the video. If you purchase anything through the link, I will also get some commission. It will help me. So in terms of software, PC software, you can do majority of the thing that you can do, and remotely you can control it via PC. But for the mobile, it has only software for Android, not for Apple. There is no software for it, and this Android app is also not from App Store. You have to download it and bypass all the security, so it's you will use it at your own risk, because I don't know what it does and what it doesn't. So definitely thumb up, the best product. Welcome to product review by Watt Hour. In this video we are going to do the review, assembly and test of this Ryzen RD6018 60 volts 18 ampere power supply with constant current, constant voltage, over voltage protection, over current protection, battery charge feature, and much more. I'm going to show you the assembly. I'm going to show you all the settings. Then I'm going to show you how to charge a battery. After that, we are going to download the software, the PC software, connect via USB, test it, and show you how to set the value. And also, then we're going to test the Android app and also iOS Apple app. Let's get started with this. In this video, we are going to do the review and test of this 1500 watt boost converter with the input of 10 to 60 volts and output of 12 to 90 volts. We are going to test it with 90 volts, 1.5 kilowatt, 1500 watts, and also I'm gonna show you the efficiency at 1500 watt and lower it, and also I'm gonna change the input voltage to 50 volts constantly